Hello everyone. The reverse assembly process is what we'll be learning today. It allows a single product to be broken down into multiple valuable outputs within the Onfinity system. Before we begin, let's quickly look at our agenda to understand what we'll be covering today. In this session, we will cover the reverse assembly process in detail. Our goal is to help you clearly understand how it is managed within the Onfinity system. Next, let's look at the objectives of this session. It enables you to understand the reverse assembly and its associated terms in the context of business process. It also enables you to test the reverse assembly process in the context of business requirements. Now let's move on to the prerequisites. Before we begin configuring and processing the reverse assembly in the system, there are a few prerequisites that must be in place. First, you should have access to the Onfinity platform with a valid user ID and password. Additionally, tenant and organization configurations must be completed and available. Now, let's begin the session by first understanding what reverse assembly means. Reverse assembly refers to the process where a single finished good is processed to yield multiple finished goods, which may also serve as components for other assemblies. This is common in industries where raw or bulk items are processed into categorized outputs. In simple terms, it allows us to break down one product into several useful outputs that can be reused in different ways. For example, almond in shell is a bulk product. When the shell is broken, it yields multiple types of almonds, such as almond jumbo, almond normal, and almond broken. This illustrates how a single raw or bulk item can be separated into different components, each with its own value and use in the business process. In the Onfinity system, the assembly screen is used to record reverse assembly records. This ensures that every output is properly captured, making the process traceable and accurate. Next, let's identify the process flow configuration tasks that are necessary. To record reverse assembly, here are some prerequisites which must be available in the system. You must have a warehouse and locator defined, a product with a bill of material, and the proper unit of measure UOM set up. Now let's review the reverse assembly use case. This will help you to better understand the practical need for reverse assembly. Now let's explore this through an example. A nut processing company receives almond in shell as a finished product. To prepare it for market and further use, the company processes it to extract different grades of almonds. The planned product is almond in shell, and the resulting finished goods include almond jumbo, almond normal, and almond broken. These outputs are stored in inventory and may be used in packaging, retail, or further assembly processes. This use case represents the initiation of the process. It shows how reverse assembly begins in practice, demonstrating how business requirements drive the breakdown of bulk products into multiple outputs that can then be utilized or sold independently. Now, let's take a look at the basic reverse assembly process flowchart before we proceed with the use case execution. The process begins on the assembly screen once the reverse assembly configuration is properly defined on the product with its bill of materials. After completing and processing the necessary details on the assembly screen, the reverse assembly comes to an end, and the system automatically updates the inventory based on the outputs generated. It is important to note that the outcome entirely depends on the configuration of the product. We will see this in more detail during the system demonstration. Now let's move on to the reverse assembly use case execution. In our use case, once the almond in-shell stock is available, it is sent to the reverse assembly unit. The process begins with shell breaking, followed by sorting and grading. Each almond type is categorized and packaged as a finished good. After quality checks, the products are stored in inventory and can be used in further assemblies or sold directly. This reverse assembly process supports product diversification and efficient resource utilization. This covers the basic foundation of the reverse assembly concept, highlighting why it is important and how it supports real business needs. Now, for a better understanding, let's move into the Onfinity system and walk through the step-by-step process to execute a reverse assembly. To begin, open the Onfinity link in your browser. On the Onfinity login page, enter your valid user ID, enter your password, and then click on Login to access the Onfinity system. After logging in, you will arrive at the Onfinity homepage. Here, you will see various mosaics that display real-time data based on the transactions recorded in the system. These mosaics provide insights for analyzing the current business position. The availability of mosaics depends on the user's access rights and the modules installed in the system. Since this is a demonstration setup, the system contains only a limited number of records and transactions. Because of this, you may not see much data reflected in the mosaics at this stage. There is no need to worry about the mosaics right now. Once actual business transactions are recorded, the relevant mosaics will automatically display the corresponding information. To proceed with the reverse assembly process, we will now open the assembly screen to create a reverse assembly. But before that, let's review the configuration required for reverse assembly within the product master to ensure the process runs smoothly later. To access this, we open the product master screen. You can search for product master using the menu search utility or navigate directly through the master data management module. Under this module, you will find the product management module, where the product master is available. By clicking on the product master, you will land on its homepage. Here, you will also find a few default mosaics related to product master, which are helpful for analyzing product sales and filtering products as needed. For example, in the product category mosaic for almonds, I can directly view the filtered records for the almonds category that I have already created. Here, we have almonds normal, almonds broken, and almonds jumbo. These are the components that need to be extracted from almonds in shell. To set this up, select almonds in shell and click on the product name hyperlink to open it in the single record view. Since our finished product is almonds in shell, we need to link all these components within it. For this, go to the Manufacturing Detail tab. Here, make sure to mark the Bill of Materials check button as true. At this stage, you will notice that the Verified check button is not enabled since we have not yet used the Process Now option. Now, navigate to the BOM Details tab. Here, you need to add the Bill of Materials. Click on the hyperlink name to open it in single record view, and then add a BOM to insert the components for the selected product. Within this screen, you will find the Reverse Assembly check button. This must be marked as true in order to configure the product for the reverse assembly process. It is mandatory to enable this setting. Only then can the product be used for reverse assembly. The remaining details have already been explained in the assembly session. Here, you only need to provide the BOM name, select an attribute set instance if required, set the BOM type as current active, and ensure the BOM use is defined as master. After completing these details, proceed to the BOM Component Details tab to add the components that need to be extracted from the finished product. Here, I have provided the configuration for this setup. For example, from 1 kilogram of almond in shell, 600 grams are defined as almonds normal, 350 grams as almonds jumbo, and the remaining quantity becomes almonds broken. Click on the BOM hyperlink to view this in the single record view. You will also notice a check button labeled Proportionate Cost. This option is used when you want to calculate the cost of the remaining components based on the current cost of the finished product. For example, let's say our finished product has a value of 100 rupees. Two of the component products have current costs of 30 rupees and 60 rupees. Together, they total 90 rupees. By enabling the proportionate cost option, the remaining 10 rupees is automatically allocated to the third component, in this case, almonds broken. This ensures that its cost is not calculated from current cost and is instead derived from the remaining portion of the finished product's value and updates accordingly. So these are the components that we have configured here. Now let's move back to the Manufacturing Detail tab. Now we will mark the almond in shell product as verified. Each time you make any changes in the BOM details or BOM component details of a finished good, the verified checkbox automatically becomes false. Therefore, whenever you add or update any components, you must use the Process Now button to mark the product as verified again. Once the product is validated, we can proceed to the assembly screen. We can directly search for assembly using the menu search utility or navigate through the Material Management module. Under this module, go to Storage Operations, where you will find the assembly screen. On the assembly screen, you can run all three processes: assembly, disassembly, and reverse assembly, depending on the business requirement. If you would like to see the details of assembly or disassembly, you can refer to their dedicated sessions, where each process is explained in depth. For this session, however, we will focus only on reverse assembly. Once you open the assembly screen, you will arrive at the landing page. Here, you can see the Create View mosaic. From this mosaic, you can directly add a new record by clicking New Record, or view existing records by clicking View Records. The landing page also has the Advanced Search mosaic, which can be used to filter records based on various criteria. For example, you can filter to view assemblies created this month, this week, or even based on today's created and unposted documents. Let us create a new record. Click on the New Record mosaic, which will open the screen in Single Record View. Here, you first need to select the organization under which you are performing the reverse assembly process. Next, enter a name in the name field for transaction identification. For this example, I am entering the name Reverse Assembly of Almonds. In the description field, you may add additional details about this transaction. However, since it has no functional impact, we can leave it blank for now. Finally, the movement date indicates the date on which this record is created and recorded. After entering all these details, the record needs to be saved. From here, we can directly add the line from the Assembly Plan Composite View, which is essentially the Assembly Product tab. This can also be accessed by clicking on the Assembly Product tab button. Let's select the product directly in the Composite View, which in our case is Almonds in Shell. Next, select the warehouse. If an attribute set instance is available, you can choose that as well. After selecting the warehouse, specify the locator and then enter the production quantity, for example, 10 units. Once you save the line, you will notice that the quantity automatically appears in negative. You do not need to enter the negative sign manually as of disassembly. The system handles it on its own. To verify more details, go to the Assembly Product tab by clicking on the Assembly Product tab button. From there, click on the product hyperlink to open it in Single Record View. Here, you will also notice that the Reverse Assembly check button is marked as true. This is informational, and it indicates that the transaction is being processed as a reverse assembly. To add the components, click on Process Production in the header panel and confirm the action by selecting OK. An information page will then appear with the checkbox Product Quantity Must Be in Stock. This option ensures that component lines are inserted only if the required quantities are available in stock. If you want to verify further, go to the Review Assembly Components tab and open the record in Single Record View. Here, you will find all the details related to the inserted component lines. Now let's move back to the header. To complete the process, click the Process Production button once again, confirm by selecting OK, and acknowledge the information message. This process will only continue if the required product quantities are available in stock. Once completed, a message stating Process Completed Successfully will be displayed at the bottom of the screen. At this point, your reverse assembly process is complete, and you can also review the cost of the products. To check this, go to the Assembly Product tab, then navigate to the Review Assembly Component tab, where the product costs are also calculated. If you want to post this record, move back to the header, click on the Not Posted button, and confirm by clicking OK. This will complete the posting for the selected record, and the corresponding entries will be updated in the general ledger, GL. This marks the successful execution of reverse assembly in the system, and with that, we conclude the process for reverse assembly. Let's now move back to the presentation to review the remaining topics. Our next topic is reverse assembly mosaics, which we have already explored during the demonstration of the assembly landing page. Within the mosaics, we have the Create View to view and add records, along with the Advanced Search option, which can be used to filter records as needed. Thank you for attending. We hope you now have a clear understanding of how reverse assembly works and how to apply it effectively using Onfinity.